The following video is brought to you by Evapco. Evapco is committed to making life easier, more reliable, and more sustainable for people everywhere. Evapco, for life. Understanding passivation and white rust. Improving real-world passivation plans for evaporative cooling equipment commissioned with immediate heat load.
For over 50 years, the evaporative cooling industry has relied on galvanized steel as a preferred material of construction due to its cost-effective combination of corrosion protection and long service life. Hi, I'm Jonathan, and today we'll be talking about what you can do to protect your investment in your galvanized steel evaporative cooling equipment. The American Galvanizers Association defines galvanizing as a metallurgical bond between the zinc and the underlying steel, creating a barrier that is part of the metal itself.
During hot dip galvanizing, the liquid zinc reacts with the surface of the steel to form a series of zinc-iron alloy layers. The resultant layers of galvanizing provide the underlying steel with a coating of superior hardness, ductility, and adherence unmatched by any coating or painting process.
To appreciate the benefits of galvanizing, let's begin with a review of mild steel corrosion. Don't let the formulas distract you. The three important things to remember are: 1. Metal loss occurs at the anode. 2. Electrons flow from the anode to the cathode. And 3. Hydroxide creates a localized high pH at the cathode, which initiates a small amount of precipitation. With mild steel, the metal loss occurs at a localized anode surrounded by a much larger cathode area. Just visit any old farm and you're bound to see a rusty tractor somewhere. Rust is a form of corrosion that occurs when iron, or an iron alloy like steel, is exposed to oxygen and moisture. Galvanized steel provides superior protection against localized corrosion if small imperfections arise. If a break in the protective galvanizing occurs, the much larger zinc area becomes the anode. The electron flows to the cathode, which is now located at a much smaller break in the protective zinc layer. As precipitation occurs at this break, the corrosion reaction is limited at the cathode before further corrosion occurs. When properly passivated and maintained, the galvanized layer can provide decades of corrosion protection to extend the service life of the steel. Hold the boat! Did you just say passivated? Why, yes. Yes, I did. As a host, it's my job to interject new terms to educate the viewer, which I just did. So let me explain. Given sufficient contact time with the atmosphere, the outer layer of newly galvanized steel will form a stable, non-porous, protective zinc hydroxide zinc carbonate layer. These reactions are known as, you guessed it, passivation. The passive layer protects the zinc from premature corrosion. The fact that a passivated layer will naturally develop over time in air is one of the reasons why galvanized steel guardrails and lampposts, along with the outside casing of galvanized evaporative cooling equipment, rarely experience premature corrosion and have a long service life. With its ability to provide decades of corrosion protection when passivated and maintained, galvanized steel established itself as the go-to material of construction for factory-assembled evaporative cooling equipment throughout the 60s, 70s, and early 80s. Flash back to the era of bell-bottom jeans, the gas crisis, and TV dinners. In those early years, water treatment was based on chromate chemicals, the dominant method for evaporative cooling systems at the time. These chemicals were typically fed in conjunction with acid to maintain pH in a near neutral range. This treatment approach was very effective at minimizing corrosion and maintaining the galvanized surfaces. However, while effective, chromate-based chemicals were found to have negative environmental and health impacts. Therefore, beginning in the 1970s, the United States Environmental Protection Agency regulated and ultimately prohibited the distribution and commercial use of chromium-based water treatment chemicals in comfort cooling towers. In response, the water treatment industry initially transitioned to stabilize phosphate programs. To avoid calcium phosphate deposition inside systems, acid was typically fed to maintain pH between 6.8 and 7.8. Customers' safety concerns created a desire to eliminate the ongoing feed of sulfuric acid to control evaporative cooling water's pH. This led to further advances in corrosion and scale control, which resulted in all organic inhibitors that could operate with water pHs approaching 9.0. As the organic chemistries capable of operating at higher pH ranges grew in popularity, reports of premature corrosion of the protective zinc layer, known as white rust, became more prevalent. And there we have it, another new term, white rust. The Association of Water Technologies defined the term white rust as a type of corrosion product that affects galvanized surfaces and is characterized as an accumulation of white, fluffy, or waxy non-protective zinc corrosion, which adheres to the surface of galvanized steel.
More importantly, a survey of AWT members identified white rust corrosion as a serious and prevalent problem, which occurs predominantly with newly constructed, installed galvanized steel evaporative cooling equipment. Meanwhile, our friends at the Cooling Technology Institute stated in their 1994 publication on the topic that untreated, white rust corrosion can seriously damage the galvanized zinc coating and shorten the life of the cooling tower. Once the zinc layer has been consumed, corrosion of the mild steel may progress rapidly.
So now we've established that white rust has become a problem for new galvanized steel in the evaporative cooling industry. And to prevent it from causing serious damage, the equipment needs to be protected. Maybe there is a pre-treatment to help protect against white rust. Remember we said that this protective passive layer forms naturally when there is sufficient contact time with the atmosphere, and that it also has to be maintained through ongoing water treatment? If one or both of those conditions aren't met, then white rust and possible reduction in equipment life can follow.
In recent years, customer preferences for shorter lead times and their requirement for immediate heat load has shortened the time that new galvanized evaporative cooling equipment is exposed to the atmosphere prior to initial water circulation. This reduces the opportunity for natural passivation to occur. Remember, higher temperatures increase the potential for white rust when new equipment is commissioned with immediate load. In support of customer requests for better commissioning outcomes, Evapco initiated a study of commonly conducted laboratory test procedures historically used to investigate the formation and control of white rust. Preliminary research results indicated that commonly used benchtop tests, including corrosion coupons, did not correlate well with data from operating evaporative cooling systems. With this insight, Evapco built industry-leading research equipment at their Wilson E. Bradley Global Research and Development Center, specifically designed to evaluate white rust formation on evaporative heat transfer surfaces. Evapco designed and produced 2 small-scale closed-circuit coolers to replicate the dynamics experienced by customers' evaporative cooling equipment that is commissioned with immediate heat load. This innovative test equipment provides the ability to study different methods of forming a stable passive layer to minimize white rust formation. But they didn't stop there. Evapco then built 4 even smaller nano coolers in order to accelerate the testing of commercially available products and increase the rate of new discoveries related to improving real-world passivation programs.
The cause and effect of white rust has been well documented over the past 25 years. Even with this knowledge, new galvanized equipment continues to experience white rust damage. So, how can you ensure your equipment is protected? By following these simple guidelines early in the project design phase. 1. Have a site-specific water analysis performed prior to selecting your equipment's materials of construction. Reviewing the quality of available makeup water early in the process provides an opportunity to balance ongoing water efficiency and equipment service life. 2. Select your equipment's materials of construction based on the results of the water analysis and equipment manufacturer's guidelines. 3. When your equipment selection includes galvanized materials of construction, build a site-specific passivation timeline into your commissioning schedule that takes into account when load will be required and the makeup water quality. In other words, have a passivation plan and share it with your project team, including engineering, construction, operations, and your water treatment vendor.
Evapco's intensive research continues for new manufacturing processes, and innovative treatment chemistries designed to passivate galvanized steel and reduce the potential of white rust formation in evaporative cooling equipment placed immediately into operation. Evapco has a strong commitment to research and development and continues to innovate environmentally sustainable solutions with water treatment systems that are designed to extend equipment service life and improve operating efficiency. Contact your Evapco representative today to learn how Evapco's extensive research can help you minimize white rust for your next project with a successful passivation plan.